So you're thinking, how can I get AI to do this analysis for me? All right, so admittedly, I used Allison Law's framework for creating some great data analysis, and I just added a few steps and details. I went through Chat GPT and one other model, and I just went back and forth and said, make this better, make this better, make this better. Was it missing? Add those things. And finally, with a lot more adjectives and details, this is what I came up with. So this is a set of steps to do great data analysis, and I'm sure you could think of something to improve it. Let me know in the comments what's missing. But at the very end, we do a manual time estimate to see how long would this have taken if it was done by hand. So, and then there's a final output. Now, I took this, I downloaded it, and I threw it into a custom GPT, called it Data Analysis and Report Builder. So we're going to test this out by uploading some data today, and we've got some Amazon stock data that I got from Kaggle, which is what Allison told me that she uses. And I just kind of Googled this, and you just kind of log in and you can download whatever you want. So I grabbed the Amazon stock data. There it is, right there. So housing prices regression. We could even use this one if you wanted. So we can download it there. And that's as easy as it is to get a data set. You just log in and download it. So yeah, there's the zip file. We open it up, and if you need a data set to play around with, that's as simple as it is. So I'm actually going to use that one because I played with the Amazon one already, and this one will be fresh. So have not looked at this one, have not put it into the agent before, and now we're just going to put it in and see what happens. So instantly it converts it into a table, and you can see here that it's putting in the correct headers there, and then it has a whole bunch of columns and a whole bunch of interesting information about the square footage. What is not here is the zip code. Oh, what location score? Okay, so it does have some kind of location information, which is interesting. I mean, I'm eager to see what it makes of that. Distance to center. I don't know what that means, but maybe the center of the city is in. Who knows? So let's see what it does, how well it does in following the instructions. And I'll show you just briefly an overview of these instructions. So first, it's going to look at the data set. It's going to figure out what's going on here. What are the key characteristics? It's going to build a data dictionary, which basically takes each of those headers, each of those columns, and says, what kind of data is this? What's in it? And then it goes to an exploration for insights, kind of doing some initial looking there. And it's developing 10 insightful, compelling, practical questions based on the findings to dive deeper into. It does a quality control step on each of these, and then it goes into answers to the questions. It tries to answer those, and the answers that it gives are provides output that's too long for any given model to just say, oh, like here's the whole thing. So you have to type in continue, and that's in the instructions I made. But then the critical analysis, review of findings, and it evaluates the recommendations there. Finally, it gives the time estimate of how long it would have taken, right? So I mentioned that. Now, we'll go through and see what it's got. So dataset overview. The dataset appears to contain information related to real estate transactions or properties. I will summarize its purpose, structure, and key characteristics after reviewing the first few rows and the overall structure. So here we go. Data dictionary. So it's just telling us what it's going to do. It's going through those steps just so we know what kind of process it's going to follow. Does some Python. It's got the first few rows here. The data says well structured, containing no missing values, as evident from the column counts. Its format is suitable for exploratory data analysis and modeling. That's great. The last one I worked with, ChatGPT did a bunch of data cleanup. So if you're thinking, oh, I have to clean the data before I put it in, like that's not true. You don't have to clean it. Now, if you want to be very intentional about the way that you clean it, then you may indeed want to do that yourself. But otherwise, you can give it instructions. And really, what I would do if I was if I was really serious about this, is I would break this down into each step, and I would double check each step in another model, and I would ask it questions and say, wait a minute, like, tell me more about this. Why, how did you get to this answer? And show me them, explain the math that you used or whatever, like, so that I'm able to double check on each step. So I'm not going to do that during this video, but I do encourage you to be quite cautious about anything that it tells you, because it can be hallucinating. If it doesn't know what to do, it'll often just make it up on the spot, and it will confidently convey those wrong facts, those non-facts, as precise truths. So you need to be very careful about that. So moving on here, it's breaking these things down here and doing some work behind the scenes in Python. Okay, it's giving me the dataset dictionary here. So here it is. It's got the 4 columns at the top. Column name. This is the number of bedrooms, number of bathrooms. We saw that in there. And an explanation of what it is. A unique identifier for each property. Total square footage of the property, etc. This is the data type. So this is an integer. This is a float. So I think it's something with a number of decimal points in it. And then these are integers. So it's broken down the number of bedrooms into integers. And interesting that it's calling the number of bathrooms an integers. You often have a decimal, a 0.5 number in there. So that's interesting. Okay, so over here, notes and assumptions measured in square meters. So it's telling us what the metric of measurement is. That's helpful. Binary variables for some of these, and higher values suggest better quality location. Okay, so that's the location score. Yep. So it doesn't tell us exactly where it is, but it tells us it tells us what that measure is, what it's talking about. Great. So continuous variable represents market price in the US price. Okay, great. So interesting that the price, they don't have like an index, because it would be nice to have some kind of like indexed price, you know what I mean? Because the price depends on the location so much. But anyway, so here's the detailed data dictionary for the real estate data set has been provided. Each column's purpose, data, and assumptions have been described. Next, we will explore the data set to uncover key trends, patterns, and insights. So this can save you so much time. Now, if this was really important to me, I would open up the data set and I would look at it. I would look at these numbers and I would probably play with it and do some like, okay, what is the mean? What is the standard deviation? What is the nature of this data set? Like, I would comb through a few hundred or a few thousand rows just to kind of get a feeling for it. Then I would have AI do this piece, and I would kind of double check and say, okay, that looks right. Like the bathrooms thing, I'm really curious about. All we really have to do, because it's popped in the into that initial, so we can look and see the bathrooms. Garage size, has a pool. I wonder if any of them have 2 pools. So 1 is 0. Oh, I think it said that was binary. Year built. Here we go. Number of bathrooms. So this, you can tell, is they're not doing the half bath thing. That was just one question I had, and you can see that by digging through. So you want to know, is Chat GPT off? Is it making an assumption that you don't agree with? And do I agree with what's happening here? And so now that now that we've looked through, we can see, oh, okay, they're obviously like among 40, 50, 60 houses, you would have some with half baths. So really they're counting just the number of bathrooms. Like if there's a sink in there, that's a bathroom. And maybe a sink and a door. I guess you could have a wet bar that's not a bathroom. So, but yeah, so digging into that data, literally looking at it, I think is still a very valuable thing. Now, you could do an analysis and then have someone that you trust look at it. If let's say that you're able to hire somebody for a lot less than you cost per hour. And let's say you're making $200 an hour and you have somebody for $100 an hour or $50 an hour that is really good at this, and then but they don't know where you want to take the analysis. You could then have them double check it and say, hey, look at this, see if it looks right, poke some holes in it, find some things that are wrong with it, and then bring me back your report. And they might throw it into a large language model and do the same thing, but they should look at it. It's that someone should be looking at that data and aligning, like, is this what we think is going on? Is this what we want out of the analysis? So moving on, data snapshot. There's the detail. Let's see. So data overview. Data set consists of 500 entries and 12 columns representing various attributes of real estate property. So this is a relatively small data set, I would say, 500. The purpose appears to be analyzing or modeling property prices based on features like square footage, blah, blah, blah. Key characteristics include numerical and categorical data describing property size, blah, blah, blah. Data snapshot below is a preview of the first few rows. So it's giving us this, so we're like, so it can see and so that we can see. And we've already seen this, but I think even if you're just going to look at 5 rows, like, that's better than nothing. Like, okay, these are actual years, like, locate, like, all this stuff's like, just to kind of wrap your head around it and make sure that you understand what's going on. Okay, so now the detailed data dictionary for the real estate data set has been provided. Okay, we already went over that. And then here's the exploratory data summary. So it's telling us unique values. There's okay, so none of the, if we were to look for the median, there is not one house size that was repeated. The number of bedrooms, year built, there were 121 unique values, so 121 years in which these homes were built, which tells us that probably that some of these homes are at least 121 years old, and potentially much older. So it has a garden. There were 2 unique values. Oh, that tells us that it's a binary because it's 1 and 0. And 500 unique prices. Okay, so that was not super helpful. Okay, we've got a graph here, distribution of property prices. This is kind of interesting. I can click on it to do the interactive. Let's see, sometimes this works and sometimes it doesn't. Oh, for this chart is not yet supported. Okay, so that was not, it usually has this little button to indicate that if it's interactive. So, but you could download it, and it downloads as a ping, or you can do just a screenshot, and you can zoom in order to get a bigger picture there if you want to do your own screenshot. And then I'm just going to zoom out here. So we're looking at this, and okay, U.S. prices. So this is interesting. So it shows kind of the top of this mound as somewhere which we would consider like sort of that median number, just still over $500,000. So that's a lot, right? And if you kind of look for maybe the mean, the kind of the middle of this mass, I mean, you could ask it, what's the mean price, right? But you can see that it's going to be somewhere around there, around $550,000. And then if you ask it, what's the mean price, and it says the mean price is 300,000, then you'd want to look into that. Something here seems wrong. But this is a nice visual there. So square footage versus price. This is interesting. And what you'll see here is that this indicates, if we threw onto this graph like that, the location, the preferability of the location, then we would probably get more of a clean line here. But I would say that there is somewhat of a line. It lifts up on the right side, but it's pretty broad. So that probably indicates differences in the preferability of the location. There's location versus price. Interesting. So the location scores, and that shows that there are small houses and large houses in each location. So this is a little bit surprising to me because I would have figured like, oh, in the best locations, there's going to be giant houses, but sometimes there's, beautiful apartments that are really, big luxury apartments. And then right next door, there could be a slum high tower, so, so there's a lot of variability there. And that's if these graphs are correct, right? I would want to see if they were. So let's do the this is only allowing me to change the color of it, and maybe it wasn't. Yeah, so I can change the color here. Say, oh, I want them to be pink or red. It's a nice dark contrast color. So did I get it, or I can make it whatever color I want. I didn't realize that before, but it didn't actually change it. So that's interesting. Let me just try that again so that you can see how that works for this one. Did it change it? Nope. For some reason it didn't. You can make it big. Oh, there we go. It's huge now. So can I make it interactive? This is the only interactive thing I can do. That's interesting. Sometimes you can, when you change it to interactive, switch to, oh, there we go. Now it works. So I had to click that button there. So now when you mouse over it, it gives you the exact numbers there, and I love this. And sometimes it even darkens the one that you're mousing over to help you out even more. So let's shrink that, and let's see what happens when we do it there. Yeah, now it's down here. So interesting. Average price by number of bedrooms. So let's actually look at this besides the color. Average price by number of bedrooms. So you can see that the average price increases the more bedrooms it has, higher the price. And it's a pretty linear looking increase there. Key visualizations have been generated to explore trends in the data set. Distribution of property prices. The prices show a positively skewed distribution, indicating most properties fall within a lower range, with a few high value outliers. Square footage versus price. So it's just going over these results here. Now, this thing did not work last time I tried it. It's like the respond to, like, what about this thing? And it didn't work last time I checked it. But not saying it won't ever work, but what I did last time is I just said continue, because it's kind of on this crusade. It says, next, I will summarize these insights and propose related questions for deeper analysis. What is that? Okay, this is I think this is the same thing that we saw up here. Let's just check that. So it starts Implement Lab, visualization, distributions, and trends. Let's just check that here. I'm curious. Yep, so this is the same thing. So what I've done in my settings is I've made it so that this the Python always shows, because I like to see the Python and what it's doing, and it always describes it here in gray. So if I didn't know what was going on, I was, oh, what's going on? Correlation between square footage and price. So that's kind of what it's pulling up there. So it's like build a table, blah, blah, blah. Nice. So that's just the same thing as up there. And then I'm going to say continue because it's suggesting the next thing, and I don't even have to think about it. I can just say continue because it's going to follow this big set of steps. All right. So now key insights, price distribution, square footage, and price relationship. So it's like it's kind of those are the key visualizations. These are the key insights. Pool and garden impact. Visual analysis shows that properties with amenities like pools and gardens have relatively higher prices. There we go. So it's given us these initial insights here. Proposed questions for further analysis. Looks great. I will now proceed to answer these questions using visualization, statistical analysis, and insights. So we're just walking through, we're just stepping through this whole thing. Adjusted distribution of property prices excluding top 5%. So that excludes the outliers, and we're seeing that this is bimodal. It's a little bit bimodal here, isn't it? Maybe that it has a little hill there. So you can see that about the middle of this is somewhere in here, around. So it's not enormously different. If you took like income, you'd probably see a much bigger difference. It's like you can see that or somewhere around 550. This thing keeps covering up the stuff, but like, okay, fine, like, no, it's this note that's like just covering it up continually. But anyway, the middle is somewhere around 550, and as it was before, so maybe it's a little bit leaning far to the right, but you'd think, well, they just cut off the top, so I'm not sure what the value of that is. Let's see what it says below. Anyway, another scatter plot there, another bar graph, has pool, and average price by pool and garden presence. So this is interesting. You might be thinking, should I put in a pool? Oh, if I put in a pool and a garden, then my will the price of my home be higher? And I think some of this has to do with, well, let's start out with the neighborhood you're in, right? So this is has garden, and let's see, let's do the little thing here. Okay, so the price of a place that has no garden, let's see, and one has pool. I'm trying to understand what it's saying here. So has pool for the 0 and 1. I do not understand this graph, but let's see what it says below. Properties with both a pool and a garden have highest average prices. The presence of either a pool or a garden alone increases average property value, but less dramatically. Okay, so there's not a lot of difference there. And again, like I would say, let's look at the neighborhood first, right? So if you're in a neighborhood where, it all depends on the neighborhood you're in and how much value that it's going to add. It might add a little, it might add a lot. Next, I will delve into other questions. So I'm going to say, actually, I realized I could just type K, and it's like saying okay. So I just have to click like literally one button and then enter, and I don't have to touch the mouse, right? So it's going to go through and do some more. Let's see what it's doing here. Statistical significance of price difference based on the number of bedrooms. So that's what it's going to look at next. Oh, it looks like it's going to do three of these. So it's going to tell us what's going on here. It's going to use an ANOVA F statistic. Okay, so in this graph, we can see the average price, older versus newer properties. So the newer are going for more, and part of this, again, like you gotta think through what it's not telling you. What it's not telling you is that houses are getting bigger and bigger and bigger. So if you look at this in relation to square feet, you would perhaps see, oh, these newer houses are bigger, and maybe it is more per square foot as well, because they're probably fancier. And also, a new house is new, obviously, but an older house, some of them have been completely remodeled, and some of them are not remodeled. They're old. They need to be remodeled. So you've got everything between, the dumpiest house that is in dire need of a remodel, and house that's just been completely, redone. So that's a big spread there, and this is like if we had that information, that years since remodel, right? I would love to know how a fresh remodel that's of the same size compares with a newer home. That would be more interesting information. It's not in the data set, so we can't compare it. But old versus new properties, on average, newer properties are priced approximately $91,000 more than older ones. So we're thinking through this, and it just like, and we could ask it those questions, or we could try and find a data set that includes that information, and we could look at that if we were trying to figure out a bigger puzzle there. Okay, so I'm going to do my K and my enter, and so I don't have to do much in order to keep it going, right? You might say, oh, this is a lot of work, but it's let me know which specific area question. And I'm just going to say, how much time would it have taken to do this analysis by hand? I'm going to say to do all of this analysis by hand. Here's an estimated breakdown. So it's telling me the data set overview, the data dictionary, exploration and insights, answers to questions, critical facts, Okay, about 10 hours. So, I mean, obviously, we haven't been in this video for 10 hours, right? You haven't been luckily watching me do this for 10 hours. We've just been kind of reviewing the work. And can we trust it? I would say no. Like, you need to dig into it a lot further in order to be able to trust it. But, you know, eventually, if you're working with a data set and you know the data set, and you're like, okay, I just need to slice and dice this a little differently, then you would be able to have a sense for, like, okay, that matches what I've seen before with this data set. I would never just do an analysis like once and then turn it into an executive. Like, just, oh, here's my report. I would never do that. I always like to look at it in several different ways and chop it, and if I can, like, ask other people about it and say, what are you seeing here, or can you replicate this? And then double checking things before I hand something off is like, hey, this is good to go. So yeah, might have saved us 10 hours in our little fictitious world, but the double checking is definitely gonna take some time. So now next I'm gonna I went a little bit out of order, but I'm gonna say write up a polished report of your findings thus far. And it'll see, you don't have to spell correctly in a prompt. Like, obviously Chat GPT is really good at fixing spelling, so it can interpret what you meant by that. Now, if I had typed the spelling error so far off that it was a different word, it could flip the meaning, and that would be a problem. But okay, so comprehensive real estate data analysis. Okay, so it's giving the overview of the data set, the data dictionary, square feet, location. Oh, but it's not. This is just a summary. You know what it's doing? I think it's trying to finish the whole thing in one. This polished report. Yeah. So I think that it is. It's giving a brief analysis because it knows it can only do 4,000 characters or so. But what I'd like to do is expand this report into, I'm going to say 2,000 words and include graphs. Okay, so it's probably not going to be able to finish in one output. So what we'll do is we'll say continue after it's done with the first piece. Okay, so it's giving it, because I really didn't like how it didn't even go through the full data dictionary. It's like, oh, here's the data dictionary, which includes these things, but it's like you want to have a complete, data dictionary. Like, it's just like a basic thing, right? So if it's not doing that, it's not doing a bunch of other stuff that we probably want. Okay, so where were we? This was the first attempt there. So here's the more expanded version, and here's the snapshot. Okay, and oh, it didn't do the histogram there that it meant to. So we'll see if we can get it to do that in a minute. Okay, data dictionary. Below a few notable entries. So it gives us a little more this time. It gives us a broken graph, so that's unfortunate. Another broken graph. Oh man, we're striking out with the graphs here today, huh? Alright, so let's see. Sounds like my kids are having a good time in the background. My wife's trying to solve it. My wife's a saint, by the way. Alright, so statistical and advanced insights talks about the ANOVA analysis, F statistic, p-value, garage size correlation. The correlation between garage size and price is weak. Interesting. That is interesting. I wonder if there was more variables involved, because really, 12 variables is not that much. If we had more variables, it might be more interesting. But if you're thinking about putting in expanding your garage in order to get more out of a property, then you may want to just consider that very carefully, right? So that's kind of what I think of when I look at these. I'm like, should we add another bathroom? Should we add another garage stall? And it's like, if your goal is merely to sell, then you might want to think about that very carefully. So I think we saw this number before in the analysis. I'm really disappointed that the graphs didn't come out. So let's see. So it did give us a big. So this is a full report. This report provides actual. Yep. So it's the full report, but it didn't include the visuals, right? So, which is kind of the exciting part, in my opinion, of a data analysis, right? It's the visualizations, it's the graphs. Okay, do it again, but make sure you include visuals. All right, let's see what it says. Please revise the report. Okay, so it's giving us the little snapshot there. Let's see what happens. It's giving us the notable things there with the up. Nope, it's not doing it. So this is a good example of like, it's not going to do everything for you. But I would say that, let's say you're thinking, okay, I want to turn in this report, but I want this older versus newer properties one. Well, we know we saw that above, right? So if you just skim up to where we saw that before, there it is, older versus newer properties. We can make it big. We can download it, So let me show you what that looks like when, like, here's the graph. So if you were building this, like, what I would do is I would be like, let's say I'm just going to make a new document. So let's say that I was going to use this output. First, I would go to the very bottom where we were, and you can copy it. Let me show you what it looks like if we copy it. It looks like this. Pretty sure that's not it. Hang on. Copy and paste. I'll be darned. So when you copied it, when I used to copy this, it would not copy the formatting, and it would just, the formatting would be disgusting. And now it copies the formatting. That is so nice. So this even came out okay. I would probably put in some borders here. So let's see. If I was going to do this, I didn't select the whole thing, but I would put in some borders. So let's see if we can do that. There we go. So yeah, I didn't, but I'm just showing, like, you can put in borders and make it look a little nicer. You can make it wider, so that some of these aren't so smashed. You can, and then what I was gonna say is, where's that lowest? Low. It was like the property values. Remember that part? I don't know. Let's just say it was some random place. So then I can insert that image that we downloaded. Remember that? So it's not going to be in the right spot here, but there we go. Like, there's the graph. So you can do that, and then let's say that you're thinking, so you wouldn't be able to change it there, but you could say, let's say we go back to it, and we're like, or let's not go back. Let's say, make a graph of new versus old home sizes. There we go. So let's say that we want that graph, and we're like, okay, this would be good to add, and it's analyzing, it's doing its thing, right? So if we look at the gray text here, categorize properties into newer and older based on something. And so it's going to do age group, year built. It's looking at the year built variable, right? It's going to look at that column. And so then we're going to go to age group, and it's going to go to square feet, figure size 10:6, plot the results. And I don't know what that means, 10 and 6, but it's telling it what colors to make these things. And here we go. So let's just make it big here. Average home sizes, newer versus older properties. Oh, that is interesting. Average size in square feet. Well, we know that this is probably in hundreds, right? But the average home in the U.S. seems like it's much bigger than that, but maybe this is including apartments. I'm guessing this is including apartments. And we could check this by Googling, but it seems like the difference is very small. Oh, wait a second. Average home sizes, it says that the older ones are bigger, so that's got to be wrong. Because watch this. Historical home sizes. Okay, average household size. This goes down. This is one of the most bizarre facts that I've come across that is just insane. So average household size comes down from 3 to 2.5. So we've got half a person less on the average, and we don't have half people. We shouldn't have a lot of half people, but that's a lot less. It's a huge drop, right? And then the light blue there is the median house size, and the average house size left scale. So these basic average numbers go up from 1,600 to 3,000. Or sorry, this is there's the persons on that side, but it goes up from 1,600 to 2,800, like 2,700 or something. I just clicked on it. So it's a huge increase. I would say a third more than a third, going on doubling, right? So if we talk about per person, it's like it doubled over time per person. That's one of the weirdest statistics that I've seen. But the home sizes are larger. That's the thing that we came here for, is that older homes are smaller, newer homes are bigger. So if we look at this, now if we go back to Chat GPT and say, oh, how did Chat GPT do at analyzing this? Then it's probably wrong. The bar chart above illustrates the average size of newer versus older homes. It reveals a comparison of the average square footage between these categories, highlighting trends in property sizes over time. Let me know if you need further analysis. Give me a bar chart with decade and home size, because I think this is where we should come up with something closer to what we asked for. And I think it's confused. I think it's giving us bad data here, and that's why I'm saying, like, check everything, do this one step at a time, and so that you can kind of, this is totally bogus, right? 1900, like, it's saying that house sizes in 2020 were smaller than those in 2019. Like, that's crazy. That's not true, right? So we know that either something with our data is bogus, or something with the and we did see that there was 121, or something with the analysis is bogus. So that, let's end on that note. Is that a good note? So just so we can make a nice complete bogus report here, let's throw in another of these. So this is precisely why I'm saying, like, go step by step, double check it, and only when you trust it, only when you've kind of and you can say, like, oh, how should I, help me do this thing? What are the steps I should use? What are some of the analysis you can use, that I can use? And it can give you ideas and stuff. If you just say, go and do it all by yourself, like, it'll go and it'll come up with stuff like this. So, which obviously is not true. Looks great, but it's not true. So, and it'll also defend itself. You're like, are you sure that's true? Like, we'll do one more thing here. Okay, so we're gonna do this. This is like the grand finale of weirdness here. I think you are wrong. house sizes have gotten much bigger. Fact. Let's see what it says. It might say, oh, you're absolutely right. The house sizes have generally increased over time, particularly in the United States and many developed countries, reflecting shifts in economic growth, family preference, blah, blah. Let's reassess and clarify the data to ensure the results align with this expectation. I will review the decade-wise data in detail and confirm. So, look at that. It's totally wrong. It couldn't possibly be, that it's, because these are like hundreds, right? It's, like 1,800 square feet, right? Or tens or something. Anyway. Data suggests fluctuations. This could indicate inconsistencies. Now I'm curious in the data set. Let's go back to the data set. So we've got this. If we grab this little guy, we can go all the way back to the beginning, and we can say, okay, let's look at this home built in 1918 and see how big it says it was. There's only 500, so I wonder if this is fake. I wonder if this is a fake. Oh, I went too far. Okay, so let's see. This home that is, here we go, 1909. We'll go to the side here without scrolling up this time. And let's see. We need the size. Where's the size? Location store, number of floors, square feet. This one is 252 square feet. That makes sense. Very small house. Here we go. Here's two more that are pretty old. Let's see. It's not that they didn't have mansions. Square feet, 80 square feet. Oh my goodness. And 173. Well, okay, but it's times 10. So it's the last one would have been, I don't remember what it was, but this would be 17. Where'd we go? 800 square feet for this 1924. For the 1901, this is 1,700 square feet. So that would have been a pretty good sized house in that day. This is 580 square feet, 1963. That's a very small house. I think this is fake data. Because it's given us such wacky numbers. So maybe it did do the analysis correct, but the data is just really weird. Let's check this. So another couple really old houses here, square feet. Yeah, that's like a really big house for those times, unless they've added on to it a bunch. But yeah, that's really big for those times. Not to say that there weren't really big houses, but the average house, and I don't know why maybe this is from one city or one little town or something, I don't know. But that's why in the very beginning I was saying you got to comb over the data, right? And we didn't do that for the sake of shortness. And here we found out, oh, you really have to comb through it in order to figure out like what you're looking at. And based on looking at that, like digging into it after we got some initial analysis out of Chat GPT, we found that this is probably a fake data set. The numbers just don't make sense. And we saw that through a couple of the analyses. So it's important to start with data that is real or that it adequately represents your phenomena that you're trying to measure and analyze. And that would probably be step one that we did not include in the analysis, is like ask, does this make sense? Dig through that data. Does it make sense? And in this case, the answer was no. And so any analysis that we find probably should not be used for any kind of decision making. If you got this far, thanks for watching. I hope that this helps you in your data analysis journey. I will see you in the next one.